Imagine a world without metals, glass, fuel and construction materials. There would be no buildings, transport, roads, industries, machines or appliances. Metals and fuels have made our social, industrial and economic development possible. All these materials come from substances called minerals, found embedded in rocks in the Earth's crust. Minerals are defined as naturally occurring homogeneous substances that have a definite internal structure. Some minerals are essential for our body to carry out its chemical and biological processes. These minerals are required in very small quantities, but are essential for the proper functioning of the organs in our body. You will be surprised to know how many different minerals you use in everyday activities. For example, brushing your teeth. The toothpaste you use contains limestone, aluminium oxide, silica and phosphate minerals for cleaning, titanium oxide for its white color, fluoride to prevent cavities, and mica for sparkle. Other examples of minerals utilized in articles of daily use are tungsten in ballpoint tips and filaments in light bulbs, nickel in rechargeable batteries, silver and argentite in photographic films, and graphite in pencils. Remember that rocks themselves are not minerals. Rocks contain minerals mixed with organic material. Here is a rock that contains the greenish mineral called cuprite, which is used to extract copper. If you pick up a piece of rock, chances are that it contains several different types of minerals. However, some rocks, like blocks of limestone, are made entirely of a single mineral called calcium carbonate. Minerals are of interest to both geographers and geologists. While a geographer is concerned about the distribution and economic importance of a mineral, a geologist is more interested in the formation, age and composition of minerals. Geologists classify minerals based on their properties. However, the properties of a mineral depend on the elements it is made of and the chemical and physical conditions in which it was formed. Here are 3 minerals made of carbon. Observe how they differ widely in their hardness, crystals, luster and density due to the difference in their conditions of formation. For commercial purposes, we can classify minerals as metallic minerals, non-metallic minerals, and energy or fuel minerals. The metallic minerals can be further classified as ferrous minerals, or the ones that contain iron, non-ferrous minerals, and precious metals like gold, silver, and platinum. If we start looking for minerals in the Earth's crust, we will find them in some very interesting formations. Let us take a look at some modes of occurrence of minerals. It is interesting to know that aluminium is found in around 150 known minerals. But only one of them, bauxite, is majorly used to extract aluminium. Abundantly available minerals that offer sufficient concentration of an element and a commercially viable process of extraction are called ores of that element. Thus, bauxite is an ore of aluminium. If we go digging in igneous or metamorphic rocks, we will find minerals as minor deposits, called veins, or bulky thick deposits, called lodes. These veins and lodes form when molten minerals are pushed up into crevices between rocks. Most metallic minerals like copper, zinc, lead, and tin are found in such formations. If we look in sedimentary rocks, we will find minerals like coal and iron ore in thick beds or layers. These mineral beds are formed due to great amounts of heat and pressure exerted on mineral deposits over millions of years. We also come across vast beds or layers of minerals like gypsum, potash, and sodium salts. These beds are created when mineral-rich water evaporates, leaving the minerals behind. We may not always have to dig very deep into the Earth's crust to find minerals. Some metallic minerals, like gold, silver, platinum, and tin, are found as alluvial deposits in the sand and soil in valleys. Such alluvial deposits are also called placer deposits. We are also saved the hassle of digging into the earth when mineral-rich rock gets weathered and decomposed by natural agents. This leaves behind the residual mass of weathered material that contains a high concentration of minerals. Bauxite, an aluminium-rich mineral, is usually found as such deposits. As you know, around 70% of the surface of the earth is covered by water. The water of the seas and oceans and the ocean floors also have rich mineral deposits. Ocean waters are a rich source of minerals like common salt, bromine, and magnesium, while the ocean floors are loaded with mineral deposits like manganese nodules. Minerals are natural resources and their distribution in the Earth's crust is not uniform. India has rich mineral resources in some parts of its territory. The peninsular region with parts of Rajasthan, Jharkhand and Orissa supplies most of our metallic and non-metallic minerals and coal. The coastal regions and parts of Assam and Gujarat have most of our petroleum deposits. The places from where mineral ores are extracted are called mines. Mining is done through large excavations on the surface, as in open pit mines or underground by digging a vertical shaft in the hard rock and forming tunnels along the shaft by excavating material. All the mineral reserves in India are owned by the government. However, in the tribal areas of northeast India, individual persons or communities lay claim to mineral resources. In Meghalaya, families lay claim to coal deposits and mine coal by digging long narrow tunnels in the ground. This practice is called rat hole mining.